Hello everyone, my name is Barbara and I would like to welcome you all to our latest Novedge webinar episode. In this week's episode, VisualARQ 1.8, BIM and Architectural Tools for Rhinoceros. Join VisualARQ's Product Manager as he covers how VisualARQ improves architectural design within Rhino. Francesc Salla is not only the Product Manager of VisualARQ, but also an architect. He's in charge of the testing, support, and demos of VisualARQ since 2010. Besides, he has a wide experience in 3D architectural software, so as a professional user of the software, he's very demanding when it comes to improving VisualARQ. Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online design software stores. We offer a huge assortment of software solutions that cater to virtually every designer's need. Put us to the test and come visit our webpage at novedge.com. And for more daily software news and limited time promotions, keep visiting the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, Modo for product design and design visualization. Modo has become an application capable of many things. Its underlying architecture allows its tool to be used in an almost unlimited number of ways. So if you work in the fields of product design or design visualization and are curious about Modo, this next webinar will show you 10 reasons why you should take a closer look. Last but not least, today's presentation is free and it's being recorded live. If you want to rewatch this or any webinar episode, you can find it on our YouTube and Vimeo channel. Just search for Novedge. And now, Francesc, I'm going to pass you the baton, and I'm going to make you the presenter so you can show us all that VisualARQ can do. Okay. You should be prompt to show your screen.
Okay.
Okay. Vamos.
Let's go.
Here we go.
So, thank you very much, Barbara, and thanks to Novedge to organize this webinar. Well, I'm Francesc Salla. I will talk about VisualARQ, which is a plugin of architecture for Rhinoceros. First of all, I would like to introduce the company that develops VisualARQ, which is Asuni CAD. Okay, we are based in Barcelona, also in the same office than McNeil Europe, so we belong to the same group, and we are in close relationship with them. And that's very, very important when it comes to develop software that works on Rhinoceros, as you can imagine. Well, VisualARQ is a plugin of architecture for Rhinoceros, and it's aimed to improve the process to model architectural projects inside Rhino. Okay, so no matter how complex the design is, the architectural design is, but VisualARQ adds some tools to make all this process easier. Okay? So on one hand, it has a set of architectural objects, the standard walls, windows, beams, etc., which are parametric. Okay, that makes it easy to work with them and apply changes in a fast way. On the other hand, it has some tools to get all the documentation out of the 3D model. That means that with a few clicks, you can just obtain the floor plans, the elevation drawings, sections, etc. Okay, as well as quantity takeoffs and lists of the objects that are in the model. I will focus this webinar with the last version we have released, the 1.8 version, which basically has we have improved the level manager. I will show you later what is it about. We have added also the section attributes on Rhino geometry. Okay, we have also improved the way to apply materials for rendering purposes. So now VisualARQ objects support texture mappings. Also, the wall layers are now displayed in 3D. I will also talk about the VisualARQ Grasshopper Components, which is an add-on for Grasshopper that allows us to create the VisualARQ objects directly in Grasshopper. Okay. Also, the new way to create 2D plan views, the tag objects, and curtain wall object as well, which is a new object in the new version if there is time. And finally, we'll talk about the IFC export, which is one of the key features of VisualARQ because it allows to export Rhino models to any other AEC platforms that can read this IFC file format. Okay, that means that all the architectural objects created in VisualARQ, once they are exported to an IFC file format, they can be read as such in the output platforms like Revit, AutoCAD Architecture, ArchiCAD, etc. Okay. Well, our development system is to develop new releases every 3-4 months. All the updates are free for VisualARQ users. The user feedback are key for the improvement of the software, so we're a bit open to receive suggestions, ideas, anything that helps the developers to improve our software. Okay, you can see here the affordable price of the software. There is also an evaluation version available for 30 days. If you need more time, you can write to me to these 2 addresses, and I can give you a key for an extension of the evaluation period. Okay, just feel free to write me and ask about that. Okay, so I will start showing the VisualARQ features with the existing model. Okay, this is a project created with a combination of VisualARQ objects and Rhino geometry. Okay, so anything can fit in a 3D model. So not necessarily just visual architectural objects, but also you can continue working with the Rhino NURBs, poly surfaces, etc. Okay, the idea is that anything can combine inside a project. For example, in this model you see here there is VisualARQ railings, slabs, walls, curtain walls, but also there are poly surfaces or surfaces as this simple here. Okay, at the end, what we want is to obtain all the 2D documentation, and doesn't matter if you have created the model using the VisualARQ object or just using the Rhino geometry. So here you can see the main 3 VisualARQ toolbars. The first one has this set of standard architectural objects. All of them are parametric. We have a second toolbar with documentation tools, okay, to generate all these 2D drawings and 2D documentation. And finally, we have some additional tools. And one of these tools is the option to work with different levels. This command opens this dialog we can see here, from which we can work at different levels in our project. In this project, we have already 3 levels, as you can see here. Each one has one elevation that automatically places a construction plane at this level. As you can see here from the front viewport, for each level there is a reference line indicating which is the elevation of the level. And on each level there is a construction plane located. So I can easily move this construction plane from one level to another one. And this allows me to work very easily with the model. So wherever I draw here, I can be sure that will be created in that -1 level. If I put the construction plane now here on the level 0, now everything is located here on that elevation, right? Extend that. Another feature of this level manager is the option to hide and show levels. Okay, actually, every time you create a level, for creating a level, you just have to click on the building and just add one level here. There is a new level automatically created at this following elevation. You can change that, of course, and each level has like a clipping plane on the top and bottom limits. Okay, that means that I can hide, for example, this level 1. Okay, and this is like activating this clipping plane located at the top of this level 1. and this allows me to display this level and see the interior of the building. This is not only useful for watching how the model is created, but also to work from here. So I can easily work from this level 1 too. So same if I hide this level 0, so what I see now is that this level -1. Okay. On the other hand, we have this icon here, which is the cut plane, that as soon as we activate it on one level, let's say this splitting plane moves a little bit downwards to this this specific height from the level elevation. And this is the height from which we usually see the floor, well, the 2D drawings of the architectural projects. If we move to the top viewport, and we activate this cut plane on that viewport, we can see that all the VisualARQ objects show their 2D representation. So you can see here the walls solve their intersections. Doors are showing this 2D representation, etc. Okay. And I can easily switch from one floor to another one just doing double click on the level 9. Also, there is the option to display the 2D objects, well, the 2D section of other floors that I cannot see. So just activating this icon, I can see the reference of the objects I have underneath, and that's very helpful for having the reference of the hidden objects I have in my model. Okay. Just clicking on here, I display everything back again. As you notice, the VisualARQ objects have some section attributes. Walls are showing this single pattern, but what happened with the Rhino geometry? Actually, the VisualARQ objects that I will show later have these section properties according to their styles, okay? According to the wall style, the door styles, etc. But what happens with Rhino geometry? So you can assign section attributes from the properties panel. There is this icon here, section icon, from which we can also apply section attributes to Rhino geometry. Okay, so we can define here some pattern for this cone, and also define some section attributes for that object. Same if I move to that floor, and for example, I want to assign section pattern to that geometry. Okay, let's put a solid pattern here. When you see that from the top, you can see how it looks like. Okay, so we can get very different kinds of representation just editing these section attributes, right? Okay. Now I would like to move to a different model. Okay, I would like to show you how would be the process to visually create a new project. So the process to start working with VisualARQ object is very simple. Okay, so for example, if we want to create a wall, we have an insertion dialog here with a list of different wall styles. We have some insertion options, and drawing walls is as if we were drawing lines. Okay, it's easy as that. And for the rest of objects, it's the same. We can insert now the door. We have a list of existing door styles. Okay, and we have just to pick one insertion option. some dimensions and just insert the door inside the wall. Later on, we can modify these objects, since they are parametric, through their control points. So in that way, they work very similar to Rhino lines or surfaces. So we can modify the position of these walls, or just using this arrow to stretch the wall like that. Okay, we can also use the vertical control arrow to change this wall height. Or if we want to modify their attributes, the properties numerically, we can select all the objects, and here under the Properties tab, VisualARQ detects which objects are selected. So you can see there is a door selected here, and you can see here the list of all the properties of the door. So we can change the width of this door, or for example, we can move to the walls and place here a specific height for all of them. Right? We can change also the style, whatever. And actually, if we do right-click on the wall icon or any other icon, what we do is opening the style dialog for editing all the existing styles. So we have here the list of the 4 styles. For each one, we can see the general properties and attributes. So we have a list of projection attributes, also section attributes, that's what I was meaning before, and also some general properties, for example, the wrapping, and just displaying this, clicking on this arrow here, we can display the list of layers that this wall style has. In this case, there is just one single layer, but again, here we have all the properties that concerns this wall layer. Okay, projection, section, attributes, construction, function, wrappings, etc. Okay, here would be the thickness of this layer. From this dialog, we can also create new styles. We could just duplicate some of these existing ones and modify it, or we can go through this the new style wizard and just follow the steps to create a new style. So we go next, and we say that we will create a 3-layer wall style. Okay, so we just need to define the name for each layer and the thickness of each one. For this one, I will create a air chamber, and finally the 3rd layer of this wall. Go next, finish. And here appears the layer we have created. Now we can just, let's put the preview in 3D. We can edit the attributes of these layers. Okay, for example, I will tell the 1st and 3rd layer to be solid when it's shown in 2D, in section views. Okay, or I can tell this inside layer to be hidden in 3D. Okay. So now I can select, for example, these walls are created, and here from the properties panel, change them to this new style I have created. Okay. When I see that in 2D, of course, I see how the intersections are shown. Okay. So now I have here some curves, as you appreciated. We will very quickly create a simple house from those curves. Actually, here under the wall command, we have some additional commands to do operations with walls. Some of them are the equivalent of the Boolean operations of Rhino, but since VisualARQ objects are actually blocks, they need their own commands to do certain kinds of operations. Okay, for example, adding solids or subtracting solids, we need our own commands. There is also some command to turn Rhino geometry into VisualARQ walls. Okay, so there is also a command for that. But I will show this command to convert curves, okay, Rhino curves, into VisualARQ walls. So I just have to select the style, pick the curves, and that's it. Okay, they automatically become VisualARQ walls. Again, I will now create the inside walls from curves, and just with a few clicks you can see that I have all the walls created. Okay, I will do the same now for the slabs. So let me just hide these walls. But first, I would like to show you that well, now we are displaying the first floor. We can remember that we can move to the lower floor from here. Actually, I turned straight lines into walls, but actually you could create any kind of curve and convert it into VisualARQ wall. Okay, so I can just turn this wall and adapt it to this curve here. And actually, now this wall has the same control points as the original curve that was created first. Okay. Right. So let's create the slabs now. I just run the slab command, and I need to pick closed curve, define some thickness, okay, and that's it. So again, I run the slab command again, I select curve, and they are created automatically. Let me create a slab from that curve. Okay. And well, slabs also have a parametric, so I can come here under the properties panel and change their thickness, for example. Okay. Or I can subtract holes from slabs. So here on the slab command, I have the option to add a boundary or subtract a boundary. So I will subtract this boundary to create here the stairs hole. Okay, so let's create the stairs then. I run the stair command. Again, I have a list of styles. I make sure I am working from the level -1. Okay, so I will create my stair from here. There is this rule icon here which is very helpful to measure the objects. Okay, and here I click the direction. That's it. Okay, also slabs have control points. Let me put that in shape mode now that the selection goes better. And I can change I will do that from here. I will change the boundary of this hole. Okay. Okay, let's move on. Now we will create the openings of the house. So I have already the elevation of this house in a simple way. Actually, if we didn't have them, creating the openings would be as easy as doing that. Okay, so I just select one window style, and that's it. Okay, but I have also the option to create windows from curves. So when I run the Windows command, I then select my window style, and rather than clicking inside the wall, I will select the From Curves option in the command line, and I will pick those curves that I have here, and the windows will be automatically created on that curve, okay? But they will be automatically attached to the nearest walls, okay? And I can do the same to the other side. So actually, windows can be created from any kind of curve, so also curves like that. I can do the same with doors, so I can select here a door from curve, so I will select this curve now. Okay, sometimes the door may not detect the proper wall, okay, so in that case we have just to move it and it will be adjusted to the right position. And again, I will create now garage door from here. Okay. So most of the visual objects, as you can see, can be created directly in the model or using to the line. So it means that we could import our VWG drawing and easily use the lines to turn them into 3D geometry. Also, the railing command has some list of styles, okay? And let me just switch on the railing layer. I select from curve option, and I automatically create a railing. Okay, I can select different railing one now, and select a curve I have here. Okay, in this case, well, I should adjust the position of this railing. I can activate the control point, so as you can see, all the VisualARQ objects have control points. Okay. Which makes it easy to modify their shape. Okay, so now let's create a roof for this house. We'll activate the roof layer. I have just here the boundary of the roof. When I run the roof command, I need first to select a closed curve. Okay, and now I am asked to define which roof type. Okay, so I have three different types of roof. So let's create a hip roof, for example. So I define the slope and the thickness, and the roof is automatically created. Okay, but I can also create a gable roof. So that's what I will do now. Select again roof. I select gable roof. Define the slope, the thickness, and also define here the axis direction. Okay. Once the roof is created, I have different options to edit it. Again, under the properties panel, and I can, for example, change the general slope, or I can change the edge cut. Right. So I can put this down, and some of the commands I didn't explain about walls is the option to extend walls to any kind of object. That can be a roof, such like in this case, or could be also a Rhino surface or poly surface, okay, any kind of geometry. So I run the wall extend command. First I will select the walls to extend. Now here from the command line I select the direction, top in this case, and the entity to extend to. Okay, and the walls are automatically extended to this object. Once the walls have been extended, they keep their relation with the object. So that means that they are attached to it. Any change I do on the position of this object, or even the shape, the walls will update automatically. Okay. Right. As you saw, we created this simple project very quickly. Okay, but now let's get the documentation out of it. So we will start by creating a section. So first we will define a section line. For example, from here, I need to specify the length of this section, because everything that later on I want to show in the 2D section view would be the geometry included in this section area. Okay. I specify some text. If I now activate the control points, you can see the area of this section. Okay, so I can change that if I want. And well, let's create another section. Actually, sections can be jagged. That means that it can go like that. Okay. And once I have the section lines created, well, before creating the 2D section view, I will show you the dynamic section command, which shows me the model section in real time, according to the position of this section line. Okay. Wherever I move this section line, the project updates. Okay. Also, again, this makes it easy to get very interesting views from the project I'm working on. Also, to work from the inside of this project. Okay. And dynamic section, well, sections everything, but to the lines. Okay. So in that case, I will just hide the curves manually. And well, now let's create a 2D section view. Here there is the section view command. First I need to specify one section view style and select one of the section lines I have in the model. I click here, and here there is this the section view automatically created. Okay, I can change this section view from the properties, so I can tell this to show the section view automatically from here. And as you can see, the objects are well, show their 2D representation according to their styles. If I had some run object here with some section attributes, for example, let's create here a kind of column. Could be like that, okay. And we would put, actually we can change, we can flip the direction of the section view from here. The drawing updates automatically, okay. And we can move that to any position, okay. And as you can see here, the section automatically updates according to the drawing. So we can now assign some attributes to this object, which is basically Rhino geometry, as I showed you before. And once I do that, I just need to select the section view and update it to see the changes. Okay. So you could, again, you could have the whole model created just with Rhino geometry, no matter how complex the project is. That finally you could obtain the elevation of section drawings using the VisualARQ. In a similar way than we can create section views, you can also create plan views, right? The process is very similar. So I will show you that from the top viewport. So we run the plan view command. Okay, we need to specify the floor we want to create. Okay, so let's create the first floor, for example, and define one area. So now I specify one insertion point, and the section view is automatically created. The plan view, excuse me, is automatically created. Okay. Whatever I keep on doing on the 3D model will be shown here later on. So I don't need to care about this 2D drawing anymore, because when I have my project finished, it will be updated at the end. For example, I can create a stair here. Okay, it goes from, let me make sure that I am working from the -1 level. And let me change the thickness of the width of this stair from here. And well, remember that we can change the control points of this slab. We could add here a boundary. Actually, it would be the easiest way. Okay. And now I could select this drawing after these changes I have done on the 3D model and run the update command, and changes will be applied on that drawing. Okay. So besides this plan view and section view commands, we have some additional tools for documentation. For example, the option to create spaces. So I can go to the top viewport, and here I will just show the level -1. Actually, this I will just adjust the position of these walls. Well, there are no doors at all, but I could just very quickly create them, of course. Actually, I could move these doors in the right position. As you can see, the doors automatically align to the right position on the wall they are inserted in. I can copy one from one door to another one, and again, it detects where the nearest wall is and automatically is oriented on the wall. Okay. Here I can just move this wall to that position. And now I can create spaces, as I was saying. And the space basically detects from one insert point, it detects the surrounding walls and calculates the area and the perimeter. Okay. So I can do the same with the other spaces here. And all the walls are, all the areas are detected. So if I modify the position of the walls, okay, as you see, this space updated automatically. For this one, I need to update it manually, but it detects the new boundary of the surrounding walls. Okay. Spaces have also styles, so I could apply here a hatch pattern for the surface area. So you can define different styles for the different uses of the house, the different area types. I can also create lists, right? So with this command, the table command, you have a list of different table styles. In this case, I just have it for opening spaces and walls, but I could create a new table style for quantifying the volume or the area of the slabs, the roof, the stairs, whatever. Okay. So we'll select the spaces in this case. So I do a cross selection here, which automatically detects the space objects, and here insert this table, which shows me each one of the space that has no name. I should type a name for each one with their values. Or I can do the same with the openings. Okay, select the openings table style. And here I create a list with the information of all the openings. I can also, there is also a command about openings to create the elevations of the openings. So I need, again, to do a selection. You can see the selection automatically filters everything which is an opening. And here, insert the opening elevations. Okay. So all the openings are automatically created. Actually, no, are created with the dimension values, with all the annotation values. I couldn't see because they were before, because they were created in an upper level. And well, finally, if we wanted to present this small project into the page layout, okay, in each viewport you can, let's put that in hidden display mode, you can specify one level. Okay, so I will show the ground floor here in this detail, and in the other one I will just show the other one. Okay, actually we could choose between showing the 3D model directly or showing this here it is, showing the 2D drawing I have created before. Okay, so the advantage of showing that is that we can print this model in vector output. Okay, and here we could just show the elevation we have created before. Okay, so moving on, I would like to show you now a little bit about the VisualARQ Grasshopper components. Okay, so we'll just run Grasshopper now. And very quickly show you how it works. So VisualARQ Grasshopper Components is an add-on that is installed separately than VisualARQ. You can find it in Input for Rhino. And from here you can create all the VisualARQ objects, okay, which work in a very similar way than the object created directly from VisualARQ. For example, we can create a wall. Okay, a wall object is here created, but you have to define some parameters to that wall. For example, we can define the path curve. So we need to insert a curve component, we assign this curve, and we plug it here in the C input of the wall. Okay. Now we can, if we want to define more options to that wall, we have here a component for adding more options to the wall. We plug it here, and this options are basically the same parameters we have in the properties panel. So, for example, we can add here height for that wall. Okay. So, if we wanted to create a door inside that wall, so we need to place here a wall component, which basically needs a point. So we'll set this point. It also needs the wall where it is placed. Okay. And we need to define the elevation of this wall because it's placed above. So I will just add more options here. And place a slider value for the elevation. Okay. So, well, since this wall is located in -3, I will define these values to -3. okay, to place it in the same elevation as the wall. And here I could assign more options to the door. Of course, if I move this point, so the door will update to the right position. I could change the profile. Okay, we have a list here of different profiles. Also, we can assign a custom profile. That means that I can have any kind of curve. Let's assign this curve to that curve component and plug it here in this custom profile component. So if I assign here the custom profile to the P of the door components, we create a door with this shape. Okay, we can also add more parameters here, for example, the aperture, to see how the door opens, etc. Okay, so basically you can create all the VisualARQ objects directly from Grasshopper, and not only objects but also styles. So we have here some components to generate object styles also directly from here. Okay, and taking this forward to more complex definition. Okay, we could generate more definitions to combine different VisualARQ objects, like in this case. Okay, to create this structure. So we have here the different components of this model. Okay, so we have like the distances between columns, the grid, and we can also specify the building height. Okay, at the end, everything all the objects we can see here are VisualARQ objects. Okay, so they are the columns, okay, the slabs, stairs, etc., etc. And if we bake this geometry now, they will become VisualARQ objects directly in Rhino. Okay, so this is detected as a slab that we can edit, keep on edit it from here. As I explained at the beginning, one of the features of VisualARQ is the ability to export to IRC file format. Okay, so if I want to do that, I just need to save the model as, and here it is. Look for the IRC file format here in the model, in the list. Okay, so I will call it test. Save it. And now we can open it in Revit, for example. Okay, to see how it looks like. So I look for my file, open, okay. In the meanwhile, is importing this file. I will just show you very quickly how it works, the tag command. All the objects have a tag reference, okay. But if I want to display it, I have to run this command, which is also a new feature of the 1.8 version. So here I have to select the objects, and the tag automatically appears. An interesting thing of this tag is that I can also display more information about the object it is referred to. So the format tells me that this tag is telling me the object name. Okay, but I can also right here tell this to display the width of this object. Okay, so as soon as I change the width of this object, okay, also the tag updates its information. Okay, so it seems like Revit opened the file. Let's have a look at how it looks like. So as you can see here, Revit imported everything, and the interesting thing is that all the VisualARQ objects are recognized as such in Revit. Okay, so floors, slabs are recognized as floors, windows are recognized as windows, etc. So we can keep on working on this model on the Revit platform or any other platform that supports the IFC file format. So this is pretty much the overview I would like to show you. I would like to help you with any question or suggestion you might have had watching this webinar. Also, I will be very keen to answer your questions. If you want to write me in my mail. Okay. So thank you very much.
Thank you, Francesc. You did a great job on stage, but I have to say also Enric did a great job backstage answering all the questions as they came in. So I think everybody's completely satisfied, but here's the email where you can contact Francesc or the VisualARQ team for further questions that you might have. Thank you so much. I will like to take the control of the screen back.
Okay.
So let's see, I'm going to make myself presenter. You should be able to see my screen. Is that correct?
Yes.
All right. Thank you so much. So I'm going to, hold on. I will continue with my closing presentation from the Novedge team. Thank you all for attending. Visit our webpage at novedge.com and check out VisualARQ 1.8. Novedge is the best way to buy design software online, bar none. For information on the latest specials and new releases on a huge array of design software, join the Novedge network and like us on Facebook, Google+, or Twitter. A reminder that the upcoming webinar will be with Modo for product design and design visualization. Get a clear view of what Modo can offer you, particularly if your field of work is product design or design visualization. To watch today's webinar or previous webinars, check out the Novedge Vimeo or YouTube channel. There's a lot to choose from on our playlist. Thanks again for joining us, and have a wonderful, wonderful day or night if you are across the pond. Thank you so much, Francesc, Enric, and all your team, and thank you for a great presentation. To the next time. Bye, everybody.
Thank you very much. Bye-bye.